Oh yeah, okay, so last class we talked about the circle equations and how to use that proportion with circumference and area to find sector area and arc length. So today we're jumping into fully area of a bunch of different shapes. So if you notice on the front page of your notes, this is essentially a formula sheet for you. And this is the formula sheet that you're going to rely on every time you're doing an area problem. It is all the way filled out for you, so what I want to take a little bit of time doing, and I'll zoom in on different ones, is I want you to highlight this the way I've highlighted mine. That way you know where I'm getting the pieces of information from. So in the first one, the area of a circle is pi r squared, where we need the radius. So if you notice, I have the radius highlighted. You also have a nice example here that Ms. Caldera has worked out for you. Then I have a review of sector area. This uses a different formula than we did last time. We set it up as a proportion instead of as an equation, but this formula will also work for you if you have the arc measure and the radius. Okay, just a couple more before I pause and let you highlight. We have our areas of parallelograms or rectangles, which should be something that you learned in middle school. And we have our area of circles. Sorry, that's not a circle, that's a whole square. As well as the area of a triangle. Those should be familiar area formulas for you from previous classes. I'm going to pause and let you highlight in an appropriate way so that your formula chart is really helpful. All right, so now that we have those normal shapes with the areas highlighted for ourselves, if we keep scrolling down this page, we have a few more shapes that we've talked about in this class. We have our trapezoid, our kite, and our rhombus. Trapezoid you may have seen before, but the formula for kite and rhombus might be new to you. It uses the diagonals, not a base and a height. So if you notice, this is a D1, D2. That's talking about the entire length of that major diagonal and the minor diagonal. Same thing for the rhombus. I'll let you highlight the regular polygon, but that is one we're actually going to discuss because its formula requires a little bit of prior knowledge. But I'll go ahead and zoom in on this so you can highlight appropriately to make your formula chart look really good. I'll pause talking and let you highlight. So the little bit of details I want to go into here, because I think most of this formula chart will look familiar or will at least be easy enough for you to read to understand the kind of problems I'm asking you for you to do today. But I want to talk about the regular polygon in detail a little bit. For a regular polygon, when we mean a regular, we mean all of the sides are the same length. So we have a nice hexagon and pentagon here that are exactly all using the same length around the outside. So the area formula uses what's called the apothem. Now, because we highlighted this, you can see that the apothem is the distance from the center of the shape perpendicularly to one of the sides, and that will be the same for whatever side we're looking at. That's called an apothem. There's some crazy math that goes into finding the apothem that we're not going to get into in this class. The P is going to stand for perimeter, which is why it's a capital P. When we find perimeter of something, what do? Add up all the sides. So for this one, we could add up all the sides, or we could just count the number of sides and multiply it by the length of that side. So in this case, like if you were just doing perimeter, you do side plus side plus side plus side plus side, or you could just do side times 5 because there are 5 sides. What would you multiply this side by to get the perimeter? 6, because there are 6 sides. If you're like, whatever, I'm just gonna add up all the sides for perimeter, cool, that's what perimeter is. You're adding up all the sides. So in a regular shape, you will need to do something about, or making sure you realize that the little a stands for apothem and the big P stands for perimeter whenever we're finding them. Now the point of today is not just finding area, because that's something you would have done in like middle school. We get how to fill in a formula and calculate using our calculator. What we're going to really focus on today is on the back side of this, which is composite figures. So I want you to, I don't care what color you highlight in, but highlight this word composite figures. Composite figures are figures that are the total area of 2 or more basic shapes put together. So when we're doing composite figures, we're going to need to be able to notice which shapes make up the larger shape in general. So if you have the picture we have in number 3, we would need to recognize what 2 regular shapes are combined together to make this composite shape. So to practice this before we actually get into these math practice problems, you guys just cut out all of these shapes for me, or somebody near you cut out a bunch of shapes. So find a partner with some shapes in front of them. And I want you to do the following. Oh, didn't scoot over. I want you to create the shapes using the shapes you have on your desk. So for example, I want you to use the shaded shapes, since these are all shaded, to create this composite figure for me on your desk. Let's see if we can do it. Oh, this is still on. So now that we see how to create these composite figures, we did kind of already address this, that we're going to split the composite figure into basic shapes. That's what we're identifying with our quick little activity here. We're going to find the area of each basic shape and then either add them together or subtract them to take them away. So our shaded shapes were the ones we would add together. And when we use the unshaded shapes, or when there is a gap in the composite figure, you're going to subtract that shaded region away. Our goal is to find the area of each composite figure, so we need to first identify what shapes have created this composite figure. What is this called? Ooh.
6 sides.
Hexagon. 6 sides is a hexagon. 8 sides would be octagon. What is this part called? Trapezoid. And we are taking them and we are adding them together to create this shape. So the work that I want to see on your papers for all of this is that the area of the composite figure would be created by taking the area of the hexagon and adding the area of the trapezoid. So notice I'm doing A with a subscript of hex for hexagon and A with a subscript of trap for trapezoid. That way I know that I'm doing the area of a hexagon and I'm adding the area of a trapezoid. But what you're going to do is you're going to flip your paper over to the formula chart side and you're going to tell me the formula for these two things. For this regular hexagon, what was the formula?
Very bottom.
It was little a times big P all divided by 2. Great. What is the area of a trapezoid formula? Very good. Okay, so now look, I have on my paper shown you what I'm doing. I'm going to add the areas of a hexagon and the area of a trapezoid. I have written down the formulas I'm going to use. And now all we need to do is find these numbers in our image. So if we look at the hexagon, the little a stands for the apothem. What is the apothem for this shape? It would be 1.6. Yeah, so we have this arrow coming in here. So our apothem is 1.6. What did the P stand for in this formula? The perimeter. Okay, to find perimeter, we need to take the side length and multiply it by the number of sides. How many sides does a hexagon have? 6. And what is the length of one of the sides of this hexagon? This is a little bit of a challenging question. I need the whole side length. Does this image immediately tell me that whole side length? No, it shows me only half of it. So what should you do with this number to get the whole side length?
Half it or double it?
Double it. If 0.8 is half of the side length, then the whole side length is double that. What is double 0.8? Maybe ask your calculators. What is double of 0.8?
0.8 times 2.
1.6. Okay. So now I have the perimeter formula there for me where I take the number of sides, 6, and I multiply it by one of those side lengths, 1.6. And now I'm going to fill in the information for the trapezoid. For the trapezoid, what is base 1? What? Just give me one of the two bases. Doesn't matter.
They have parallel line symbols on it. She highlighted it. What's one of the bases?
1. Okay. What's the other base? 2. And then I'm going to multiply that times the height. What is the height of this trapezoid? 1.5. So we see we have all of the values that we need from the picture itself. They may give you extra information. They may give you just enough information. But at this point, you turn to your calculator and you do this in multiple parts. You first find the area of the hexagon, so before the plus sign. In your calculator, do 1.6 times 6 times 1.6 all over 2. Say again? Do you use the what? You can use the fancy fraction, yes, but I will want decimal answers. So if it returns to you a fancy fraction, you will have to turn it to a decimal. It should be 7.68. That's what you got? Okay, so we got 7.68 as the area of that hexagon. We now need to do the area of the trapezoid. So then we go to our calculator again, and we do 1 plus 2, divide by 2, times 1.5. Again, that fancy fraction may come in handy if you're not strong with your parentheses.
Some of y'all need to be practice putting this in your calculator so that way you know where you're gonna make mistakes now. When you do your assignment, you're not gonna know how to put it in your calculator. Go ahead and try practicing it now.
Did you get 2.25?
I can go to the rest when we come back.
Obviously, the last step, we just need to add these two things together. So in your calculator, 7.68 plus 2.25, what do you get? 9.93. Now, I'm going to be a stickler for this. If you do not give me the correct units, it is not correct. What are we measuring in here? Inches. But since we found area, should I answer with just inches? Inches squared. Very good. I'm going to be a stickler for that. Area is a square unit.
Because you're going to be mad while you're, then think you got 100. If you don't put the correct units, wonder why your paper's at a 50. I got all the answers right, but you didn't put the units correctly.
So it's because we're finding area and it's a two-dimensional value. So it's length times width or whatever. That's two dimensions we're multiplying together, so the units get squared. When we get to volume, when that's a three-dimensional thing, that'll be cubed. Yeah. Okay, let's try another one. So in this composite shape here, this one is a little bit more challenging to recognize the shape, so I'll give you the first one. The area that we're going to find is going to be the area of a sector, which is part of a circle, and we're going to add this bit. What is this part called? Don't overthink it. A triangle. So we're going to have to add the area of a sector to the area of a triangle. But no worries, because both of those formulas are on my formula sheet for me. I'm going to rewrite that word triangle because it looks funky. So for the area of a sector, tell me what to write down. Arc measure. If I could spell measure correctly. Arc measure over 360, right? Multiplied by pi r squared, correct? Okay. What about the area of a triangle? Base times height divided by 2. Okay. Once we have the formulas written down for ourselves, which we just got off of the front page, we just need to fill in the different pieces of information. So based on this picture, for that sector that we have, what is the arc measure for that sector? If it's over degrees, you're looking for a degree measure. 60. So this right here is your arc measure. So we would have 60 degrees over 360 degrees multiplied by pi, which is a button we press on our calculator. And then we need the radius. What is the radius of that sector? Ooh, the radius, that 4 is on the altitude of that triangle, actually. Remember, a radius is like the length from the center of the circle to the outside. So this ends up being your radius, which is what? 7. The sector is kind of difficult. Then when we get to the other part, we need a base and a height, and we're going to divide it by 2. But for that triangle, what is the base? Ooh, the base? 7. Very good. So that's 7. And then what is the height? 4. So then we turn to our calculator. Remember, you're going the whole first area, so the sector can go in all at one time. Fancy fraction for 60 over 360, pi button for pi, parentheses squared around the 7. And then the area of the triangle you do separately as well. I'll give you a few seconds to try to get me a final answer here. Go all the way to the combining. I guess I should highlight the... Remember, I like doing this in 2 parts. You can also, I mean, it's all numbers, so you could put it in the calculator at once, but I like to see the area of each shape. So the area of my sector ends up being 25.66, and the area of that triangle is 14, which means when we add them together, the area ends up being 39.66, but if you just answer like that, it's wrong. What do I have to put behind it? Centimeters squared. Very good. Okay, that's a good point. If you get confused when the little dot is used for parentheses, remember, or for multiplication, you can use parentheses to indicate you're multiplying. So maybe that's a stronger skill for you there. Now this last one that we're going to do as a class is number 5. If you were trying to build this with those shapes that we had in class, what 2 shapes would you be using here? The shaded square and the unshaded circle. So that means to make this shape, what we're going to want to do to find the area is take the area of the square and then do what with the area of the circle? Subtract the area of the circle. But after we've set it up like this, it's just like the other problem. So we go look on our formula chart for the area of a square, which is side squared. And we're going to subtract the area of a circle, which is pi times r squared. Okay, help me fill this one out. For the side length of the square, what is the side length of the square? 16 inches. So, okay, we've got a 16 right here, and we're going to square it to begin. And then I need to subtract pi and then r squared. What is the radius of that circle? It's a good question, right? So if I were to redraw this right here, how far is that diameter? No, diameter? 16. So if I just want the radius, how much is that? 8. Half of the side length will be the radius of that circle. So I know that this radius is 8. So we turn to our calculators again and we calculate. We would do 16 squared, which is 256. And we would do pi times 8 squared, and pi times 8 squared is 201.06. And so when I subtract those, and I'm fast forwarding through the math here because you've shown me you can use your calculator already, is 54.94. And then what do I put behind it? Inches squared. Okay. I think we're ready for our classwork. I will tell you on your classwork, some of the pictures don't have units listed. So if you look at number 1 on your classwork paper, see how those numbers are just 27 and 15 with they don't have like inches or centimeters or anything behind it. That means when you write your answer, you will put units squared at the end. Like spell out the word units and then square it, since we don't know if it's inches, centimeters, feet, whatever. Okay? For the rest of class, you have 11 problems to work on. These are due before you leave. 11 area problems. Some of them are just basic area of different shapes, and some of them are composite shapes. I will put an answer key up on the board so you can check your work as you go, but I need all of the work like you saw here or on the front page of these notes for full credit.